Today we're starting chapter 12. We're going to skip over 12.1. It's just kind of drawing fancy things on graph paper. So the first thing we need to do is talk about a new kind of figure that we haven't really studied this year in geometry. In chapter 12, we're doing things in 3 dimensions. And we're going to start looking at these, we call them solids, that we're going to call polyhedron. So I've got a couple of examples of polyhedrons for you. Got this red one, purple, green, blue, and yellow one. These 4 over here are ones that we're actually going to start measuring today. And then this purple one we'll focus on next time. So what is a polyhedron? Well, a polyhedron is kind of like the 3-dimensional version of a polygon. If you all remember when we studied polygons at the very beginning of the year, we said polygons, they're in a plane, they're closed figures, and every side is a line segment. So the 3-dimensional version of that would be, it's a closed solid, and every part of it, instead of being a line segment, is actually going to be a polygon. So all of these are made up of a bunch of polygons connected to each other, and they close the figure. Like here, this red one is made up of a bunch of rectangles and squares, all of which close this solid. Same with this green one. I've got a hexagon connected to a bunch of rectangles, and then at the bottom, another hexagon. And then this blue one, I've got a triangle connected to some rectangles that connect to another triangle, so on and so on and so on. So the difference between these 4 here and this purple one is this purple one doesn't have 2 faces. The parts of our solids, our polyhedrons, we're going to call the faces. So each polygon is a face. Here, this doesn't have 2 faces that are parallel and congruent. All of these other ones do. Even this star shape here, I guess it'd be a decahedron, because no, actually that's even wrong, dodecahedron. So I've got a star or a decagon, and then another decagon at the bottom. And whoops, a little too fast there. So I've got this decagon on bottom, the one on top, and each part of those decagons is connected to the other one through these rectangles. Same with this triangular one. I have this triangle connected to another triangle. Those 2 triangles are parallel and congruent. With this green one, I have a hexagon, another hexagon, both parallel and congruent, connected by rectangles. So these 4 we're actually going to call a prism, and that's the definition of a prism. It's a polyhedron where 2 of your faces are both parallel and congruent. Those 2 faces we're going to call bases. So I'm going to focus in on this. Whoops, this green one here. For this green one, my 2 bases are going to be hexagons, because those are the 2 things that are parallel and congruent. I've got this hexagon up here. I've got another one at the bottom. Those are parallel and congruent. So what I would do is I would call this thing a hexagonal prism. Some people say hexagonal just because of different accent, whatever you want to call it. The whole point is you need to identify, first off, it's a prism. Second, what are the bases? That tells you what kind of prism. Here I'm going to have a triangular prism because the bases are triangles. I know people think of base as top and bottom. That doesn't always have to be. With polyhedron, the bases are really just those sides that are parallel and congruent. With this shape right here, that would be this triangle up front and this triangle in the back. This would be a rectangular prism because I have rectangles that are parallel and congruent, and those are my bases. Now that we've identified the bases, we still have a whole bunch of other faces. So like if I go back to this hexagonal prism, I've got the hexagon on top, the hexagon on bottom, and then I have all of the rectangles that connect those bases. The rectangles that connect those bases, we're going to give those a name. Those are called the lateral faces. Think of lateral as like the side faces. So this rectangle right here, this darker one, and if I go around the whole thing, I can identify all of those lateral faces. So I've got 1, 2, 3, 4 different prisms. Every prism has bases. Those are 2 faces that are parallel and congruent. And then the rectangles that connect those bases are going to be called the lateral faces. One last thing is the height of a prism. It's not always the up and down distance. Height of a prism is always the distance between your bases. So for this hexagonal prism, the height would be from this top hexagon to the bottom one. For this triangular prism, the height is going to be the distance from here to here. It's kind of a side-to-side length. So height is always distance between bases. That's it for the basics of 12.2. I'm going to post more videos of some applied problems and how we're going to come up with surface area and how we're actually going to find that stuff.